Artificial intelligence, AI, and quantum computing are two cutting-edge technologies that are revolutionizing the way we think about data, computation, and problem solving. When they come together, they have the potential to solve complex problems much faster and more efficiently than ever before. Understanding artificial intelligence. AI, in simple terms, is the ability of a computer or a machine to think, learn, and make decisions like a human. Imagine a robot that can play chess, a computer program that can predict the weather, or a virtual assistant on your phone that understands your voice commands. These are all examples of AI in action. AI works by processing large amounts of data, learning from it, a process called machine learning, and then making predictions or decisions based on that learning. Enter quantum computing. Quantum computing is like giving AI a supercharged brain. Traditional computers use bits as the basic unit of information, which can be either a 0 or a 1. Quantum computers use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a principle called superposition. This means they can process a vast amount of information simultaneously, making them incredibly powerful for certain types of computation. AI meets quantum computing. When you combine AI with quantum computing, you get a powerful tool that can process and analyze data much faster than traditional AI. This can lead to breakthroughs in fields like medicine, materials science, and environmental modeling. Examples in pop culture. Tony Stark's Jarvis in Marvel's Iron Man. Jarvis, Tony Stark's AI assistant, is a great example of an advanced AI system. It can process massive amounts of data, learn from it, and assist Tony in making complex decisions. Imagine if Jarvis were powered by a quantum computer. Its ability to analyze data and simulate scenarios would be exponentially faster, helping Tony design new suits and tackle global threats more efficiently. The Matrix. In the movie The Matrix, the AI that runs the simulated reality is incredibly advanced. If this AI had access to quantum computing, its ability to simulate an entire world where millions of people live unaware of the simulation would be much more plausible. The AI could instantly process and adapt to the actions of each individual in real time, making the simulation almost indistinguishable from reality. Real-world implications. Drug discovery. In medicine, AI and quantum computing can revolutionize how we discover new drugs. AI can predict how different drugs will work, but it's a process that requires immense computational power. Quantum computing can speed this up, analyzing millions of potential drug combinations in a fraction of the time it takes today. Climate modeling. Climate change is a complex challenge because it involves vast amounts of data and requires the modeling of numerous variables. AI can help in predicting climate patterns, but with quantum computing, these predictions can become more accurate and faster, helping us to better understand and tackle climate change. Challenges and future. Despite their potential, both AI and quantum computing face challenges. AI requires large amounts of data and can sometimes make biased decisions if the data it learns from is biased. Quantum computing, on the other hand, is still in its infancy. The machines are complex and sensitive, requiring conditions like extreme cold to operate. However, the future is bright. As we continue to advance in these fields, we can expect to see more powerful and efficient AI systems capable of solving some of the world's most pressing problems. The combination of AI and quantum computing could lead us into a new era of technological advancement, with capabilities that we can only begin to imagine. In summary, the fusion of AI and quantum computing represents the merging of two powerful technological frontiers. While still in the early stages, their combined potential is enormous, promising to transform industries, enhance scientific research, and revolutionize our approach to problem solving.